If we look at a triangle, a right angle triangle, and put our right angle there, and in trigonometry, or even in geometry, it's common to use Greek letters. Theta is a Greek letter of the alphabet, and it's common to use theta as an angle. We could use alpha or beta. All of those three probably are the ones that are used most common for angles. And so theta is an angle, could be 20 degrees, could be 30 degrees. We don't really concerned about how big it is right now. If we measure the ratio of the vertical side there to that side, we could write it down. So if we went A, B, and C, so the ratio of AB, so we measured it, got it in centimetres or millimetres, we could write it down, over CB, and then we extend it out, straight line, going up here, stop anywhere you like and go down, make that also a right angle, we'll call that EF. So we've got EF over CF, right angle, so we just measure that and put them down, continue this line out, G, go as long as you like, H, these don't have to be the same lengths or anything like that, you can stop anywhere you like. So in effect CG is one straight line with A and E on it, so even though I haven't drawn it too well there. So we measure GH over CH, and you would find when you work those out and divided the length of AB by the length of CB and the length of that by the length of that, you would find that all those would be the same decimal, exactly the same. So when we talk about this angle here of theta, this ratio of that side to that side is always going to be the same no matter how big the triangle. So what mathematicians did said, right, well, let's give it a name. So it has to be a right angle triangle. If this is the angle theta, then if you were, say this is a triangular room, you were sitting in this corner and you're looking out there, well, this would be the opposite. Opposite. Let's learn to spell, opposite. Okay, so that's the opposite of theta. This one here is the adjacent side. And you know that the angle opposite a right angle is always called the hypotenuse. So what we were talking about up here is the opposite and the adjacent. That ratio of the opposite to the adjacent is what's called the tan of the angle, tan of theta. Tangent, tan is short for tangent, but that's the name of the ratio of the opposite to the adjacent, any sized triangle, and that ratio will always be the same. So for instance, the tan of 35 degrees, doesn't matter how big the triangle is, that's always going to be the same decimal. So that's opposite divided by the adjacent. So then they actually said, well, right, what about if we measure the adjacent to the hypotenuse? So adjacent to the hypotenuse. adjacent to the hypotenuse. Well, they actually worked out that, let's use another colour up here, this one divided by that one turned out to be the same as that one divided by that one, turned out to be the same as that one divided by that one. So they said, right, it's going to be the same for this angle theta. So let's come up with a name for that, and that was the cos of theta. So that ratio is the cos of theta. Cos stands for cosine, but we don't tend not to write cosine. And tan is short for tangent. Once again, we abbreviate it to tan and abbreviate it to cos. And the third ratio we can get from here is the opposite to the hypotenuse. So that is the sine of theta is equal to opposite side to the hypotenuse. Okay, so we've got three trig ratios that apply to right angle triangles. It has to be a right angle for these three ratios to work. And we've got the tangent, which is the opposite over adjacent, the cosine, which is the adjacent over the hypotenuse, and the sine is the opposite over the hypotenuse. Now there is what's it called, an acronym? SOHCAHTOA, sine, opposite, hypotenuse, and that gives us this one. This one here, cos, adjacent, hypotenuse, and that gives us that one. So this is just a short way of remembering how these trig ratios work. And then you've got tan, opposite, and adjacent. And that gives rise to the first one we looked at. SOHCAHTOA. If you find it hard to remember these ratios have to be remembered, put in your memory bank there somewhere. SOHCAHTOA is probably a good way to remember those. So just reiterating that these ratios, these three ratios in trigonometry, sine, cos and tan, only apply to right angle triangles, and we'll come back and do how this is applied in situations and what we use it for.